Hey everybody, this is Larry. This is me going with Q4 of the weekly contest 238, maximum building height. This was a tricky one, so hit the like button, hit the subscribe button, join my Discord. Let me know what you think about this problem. So there are two components to this for me. One is a greedy component, and then the second is a constraint component. So the greedy part we'll go over a little bit, but for now, let me pull up a paintbrush for a second. Hang on. But the idea here is that for this one, you have a line. The idea for kind of what I call a filter step is just making sure that our constraints are good, right? And what I mean by that is, okay, let's say you have a constraint here and you have a constraint here. If you do greedy, okay, let's actually move this out a little bit longer. Let's say you have a constraint here and you have a constraint here, right? If you do a little bit greedy, you may try to go here, but then it just doesn't go fast enough, right? Like you cannot go down to meet this one. So what we had to do was just a filter step to make sure that we'll process this. We can go some amount here and do here, right? But something like that. I mean, this is a very rough drawing. But that's basically the idea. The idea is that, okay, we want to do one filter through the array, the restrictions, so that so that we eliminate these ones. So that's basically the premise of what we're trying to do, and I will go through it very quickly. So let me go back to the code because now I can go through that step. So the first thing we do is we sort. So we sort. This basically, just puts the restriction in order because it doesn't make sense to kind of, like it just allows us to do it in order. And I do this one more thing where I put a fake restriction at the end, meaning that if the last element doesn't exist, we set it to infinity or we set it to n, which is effectively infinity, so that we just have it's a set in no value. We set it so that's easier. For what we said about to remove restrictions, we use a stack-based algorithm. So basically, the idea here is that the key part is this part where, okay, so stack, we just basically, the stack allow us to look at the previous restriction and ask ourselves if this is good compared to the current restriction that we're processing now. So this is the current restriction that we're processing, and this is the one that we want to see if we still need it. And the logic we have here is that, okay, if we're going downwards, right? If we're going down, then the delta of the difference has to be possible, meaning that if the space between two restrictions is, let's say the space between two restrictions is 5, we can have some examples here. Let's say we have a constraint that's like 100, 100, and then the next one it's say, 101, 5, right? In this case, that this restriction doesn't matter anymore because it gets dominated by this restriction. Because, I mean, you can maybe do some math and just say this is 6 if you want to do another math. But the reason why we kind of pop this, and there's an implicit restriction that's already, this restriction is already implied by this restriction, right? So we could just remove this one because we want to keep going through the stack because you can imagine that this is good, and then you have a 99, 101, which satisfy the 100, 100, but this one dominates both this one and this one. So this is why we have this stack solution. And basically all this saying is, okay, this is the amount of space we have. This is the height that we're trying to delta. We can only delta one at a time. So if this is too much, then this restriction dominates. So so that's basically the idea here. And we just pop them one at a time. So that's basically how we handle this part. Yep. And then now the second part is hard as well. for me anyway. So now we know that we did this filter step. So then now we can greedily look at each we can look at two adjacent constraints, starting from the beginning constraint of 1. At x is equal to 1, the height is 0. So using that, we have a dx dh. Again, we bound the constraint a little bit, meaning that if the dh is too high, we can't do it anyway. So I just kind of bound it. I don't know if so this is basically the maximum that we can do. I don't think this one actually matters, but I still did it anyway. And let's say we have this magic function that tells us the maximum height between two adjacent points. Then we can, and we'll go over this function in a second. But yeah, let's say we're given this function, then, and maybe there's an one way of doing it, but I did it with binary search. And then now we just, the best is now the last height times the max delta height. And yeah. And then now we just said less x is equal, this is now the new x. And then the last height is just the last height times the dh, which is, the dh that we given before. Except that this is bounded by the dx. So basically, this is just the new height that we've given. And now we've tried to figure out this magical function. And yeah, so given the amount of space we have, given the space that we have, and this is the max height, we just try to figure out the binary search. I have a lot of videos at a binary search, so you can look into those. Okay, I just had to double check that I don't have my drawing still on screen. But yeah, but basically this is a binary search. The cost function is that, okay, so let's say this is the maximum delta, right? So what is this function doing? Given dx space and dh height difference, what is the max height in between this range? That's basically what this function is asking. So then the cost function is the one that is a little bit confusing. Let me remove my debugging code. But yeah, so let's say we're able to go to mid height. We're going to mid height. What is the cost? So basically, and this is a greedy way, right? And this dx is we denormalize it so that we assume that we start at 0.0. You could do some math if you didn't, and that's why I have a dh is the height, right? So then the space that this requires, and if you have extra space, you can just fill out with the same height. So that's why we can ignore that. But let's say this is mid height, right? Then it takes mid distance to go from 0 to mid, and then here it's the distance from going back from mid to dh. So if dh is 0, meaning that you have the height, then it's gonna be mid times 2, which makes sense because you go straight up, then straight down. If dh is higher, then you can go higher and then lower a little bit, and so forth. I just wanted to make sure that if dh was, if dh was negative, we don't, meaning that we're able to go lower, but then we just make sure that it is bound by 0. Though I don't think it. Maybe it doesn't matter that much. No, it should, because mid is the result that we're doing. But yeah, and this is just standard binary search stuff. I know that I usually go through that binary search more deliberately, but for this one, I'm going to skip a little bit because, there are a lot of different binary search problems. So if you're struggling with binary search, practice those problems first because those are easier to do. I know I'm a little bit hand wavy, but yeah. And in this case, the cost of this one is just going to be log of 10 to the 9, which is about, let's just say 30-ish, 30 loops is what I mean for this. And you can see that this is pretty cheap per loop. So yeah, so then now now we know that here the stack at first we did nothing, so going over the complexity now, and yeah, this is the solution. The stack this is going to be linear time and linear space for this portion. Hope that makes sense, because this is just going through a stack, and each item going through the stack will be popped or pushed once. So linear time, linear space for this portion. For this portion, you can see that stack has a linear number of elements, and here the cost is going to be dominated by this thing, which is O of I say log U, which is the size of the universe, which is 10 to the 9. So this is n log U time U, because for each restriction, this is going to be dominated by this cost function. And we shouldn't forget that we did a sort in the beginning, so that's going to be n log n. So in total, so yeah, total time is equal to O of n log n plus n log U, and total space is O of n for the stack, and I think that's pretty much it. But yeah, cool. That's all I have for this problem. I'm gonna make this smaller so you could screenshot it maybe, or you could just pause at different places. This is actually a little bit small. I have a lot of code on this one, so you would just have to, take a snapshot here and then maybe here. Okay. But yeah, that's all I have. You could watch me solve it live during the contest next. I probably could have solved this one much quicker. I had an off by 1 on my binary search. So as I was saying, that's not my binary search. So I had some mistakes even then. So yeah, it's very easy to make mistakes here. But yeah, I struggled with this one mostly on I thought I solved this problem before in Codeforce, so I spent too much time Googling it, trying to find my code on a problem, but I probably could have just done this much quicker. Because I think maybe there's a formula for this, but I don't know. Actually, I think that there's definitely a formula for this, because it's just, it's just like the length minus delta over 2 or something like that. So you can cross it or something like that. I don't know. Let me know in the comments. But for me, I didn't want to think about this, and I thought that the cost function would be a little bit more intense, so I just did a binary search, and luckily it was fast enough. But yeah, like I said, that's all I have. So watch me solve it live during the contest. Oh, actually, the time just, it is now midnight. So let's see if let's see how people did this problem. Okay, is this updated? No, maybe give it another minute. Okay, well, this is awkward, I guess. I thought they push it up, because I think the contest is over now. But oh, there we go. Yeah. So yeah. I don't know how this happens. I think they just But yeah, it seems like they did not do binary search. Just the quick. These codes are not that readable, but yeah, and they kind of went through their way to do the prefix things. But yeah, so apparently you don't need to do binary search. So my solution is way more complicated, but it is all from first principles, and the way that I did it allowed the math to be a lot easier. But yeah, apparently people did the math. But yeah, that's all I have for this one. I did it with binary search. So hopefully this shows you that there are different ways of doing it, even if it's a little bit messy, or yeah. And apparently, yeah, you don't even need to know math, because I didn't. So yeah, that's all I have. Let me know what you think. And as long as you get an AC, is good. And you can watch me solve it live during the contest next. Tell me, Larry. Okay, 6 people have gotten this. Where am I right now? I'm a little bit slower than I am usually, especially with the 5-minute penalty. 2047, yuck. This is definitely a Codeforce problem though, but because it's just greedy. But unless, let's see. I'm right now just looking for my code to see if I have to. Yeah, I know how mathy it is, but I don't, you know. Because I remember this one has a lot of if statements. What if this is impossible? Oh, well, I guess it's not impossible. It's just less than. So that's a constraint. Yeah, I could do it. I could just do it, Larry. Stop trying to find your own solutions. Okay. This IDI. Oh. Plus x equal how long did they take? 7-8 minutes. Okay. Just trying to gauge a little bit of how much time I should prepare for it. A lot of wrong answers too. Basically, it's just case analysis and with a lot of weird maps. This was a problem that I thought was just. It's just a lot of maps. Okay, so. If Oh, I guess that's actually, no, you can't do it that way because a later constraint might constrain it a little bit earlier, like this one. Or like you have to be forced to go down. Um, How do I do it then? Two constraints, for example, the 7 forces. Now they did very well to not show the hidden case, but there's a one that is, for example, like if 6 was height 5 and then 7 was height 1, you have to care about the height 1 more. But 嗯 we could do it with stack. It's not that big of a deal. Mm, okay. Oops. See, that's why they don't give you good things. That's not right. Well, I mean, that's fine. No. Is it? Yeah, I guess that's fine. What I'm thinking is this doesn't make sense. No, last successful. That's not right either. What am I trying to represent? If the delta of x is greater than delta of height, you just remove the older one, right? But only if the height is lower. That doesn't seem right. The other way. If the height is greater than it, then we don't care about. Oh, how am I got literally every sign wrong? Okay, this is good. This is what I want. And then now we can do the math. This is, I don't know why they make it so mathy these days, but okay. This is all a math problem. Because then it's just like, this is a binary search. Or can I do, is there a formula? So basically, that means that to get it's gonna go over that actually, right? In theory. No, I guess that's not true. Give a minute. It would take So it would take mid to go up, and then so if we have DH, we have the mid to go up. How long would it take if this is DH? Okay. So it would take mid to go up, and then to come down, we go from mid to DH. Right, because if DH is 1, then you have to take that many. Okay. If the cost, if this is, so this is good. If this is, if the current mid is good, then we want to take the right as equal to mid. If it's no good, then we exclude it. Okay. Maybe. Then yeah, okay. Well, worth a shot. -1, that's not true, right? Did I do this wrong? Oh, I did do this wrong. Okay, well, it's still wrong, but it's nice to know dxth1. Why? Because cost. Oh, did I do this wrong? So if this is good, then we, oh, I messed up because we want to maximize it. Okay, so if this is good, then we want to see if we could get more. So, okay. We also two. Okay, still very wrong, but maybe slightly better. This is not that close, but okay, let's see. Dx this one. Sounds right. 2 dh is not -1 though. Why is dh -1? Oh, whoops. 2052. This one's wrong. Oh, because we have no restrictions. Oh. Okay. How do we? I mean, I think that's not that bad. We just have to kind of. Just have to add in last building. Okay, fine. I guess actually we can just do this. Also, I don't think we need this stack thing because this is implicit in it. No, that's not true, is it? No, this is wrong. No, I mean, maybe with the stack is right, but it's still. No, I think we need a stack thing. I don't know though. This is going to be sketch. Doesn't really matter what this is, I guess. Can't tell where the ID should be. Oh, ID should be this, so I messed up. Okay. That's a good test case actually, because I would have messed that up. 2557. That's not good. Oh, the 7 makes sense actually, because I forgot that I didn't keep track of the end. But so this looks correct, but I don't know. I have to test this. I don't feel confident about it at all. I just have to give it a print statement. Okay. That's basically, let's see. Okay. This is the big one. Okay, so this gets rid of that correctly. Because without this stack, I think this just gives me a really wrong answer. Yeah. Am I confident about this? Yeah, I mean, I'm going to get a wrong answer, but maybe I could take a look to see what the answer is. Because it's going to take me longer than 5 minutes to come up with this case, probably. Okay. Oh. I'm just pasting my test cases so I have an idea. Okay, so this is okay. Why do I get 3 instead of 2? This 2 is good. Okay, so this is back to 0. Go to 5, it's 1. 6 is 2. So 6. We got it off by 1. Let's see. So 6 is 2, 7 is 3, 8 is 2, 9 is 1. So I'm off by 1 in this case. That's fine. Is this wrong? What's oh, because th is negative, so I've messed up here. No, this is right. Then okay, let's see. If this is 3, the cost is 3. Oh, sorry, if the cost is 1, it's 1 plus 1 plus 1 minus 2, so 3, so this is 4, the cost is 4, the dx is, so we should choose a smaller one. Yeah, why? That's weird, isn't it? The things we do because we're a little silly. So the cost is 4. We know that that's too expensive, so then we try to set the right to mid. Right? Yeah. And then after that, it tries to do 0, which is good. And then, oh, I have an off by 1. What am I doing wrong here? So with the cost, because mid is 0. Basically, I'm just so if this is cheap enough, we do this, right? So okay, so I've messed up on my binary search. So I got the first number that it is not true. But what I want, it is the first number where this is true. So if cost is, let me just do this actually. I mean, that looks right for this case, but is it actually right? 144. So it's off. My binary search is weak, and that's what's happening here. Okay. So basically, we get the first false, which is not true. What we want is the last true. And this is the last true if so on the right. Why is my binary search so bad? So this is the cause. So I have to invert it. Okay, I mean. Oh yeah, okay. So that's what, yeah, I'm. Is the answer 1? I don't think the answer is 1 though. So I think I messed up here as well. So this can be bigger. If this is too much, then yeah, no, this should be wider. And why is this wrong? Dong dong dong. Zero. 5-1 makes sense. 6-2. Yep. Yeah. Okay. Why am I printing the wrong stuff then? Well, because max delta is negative because of this. What's this supposed to return? Max delta is. Does that make sense? I guess that's okay. Why though? So now this returns 0. Yeah, this returns 0. Oh, wait, what? Oh, okay, that's just dumb. I left it in there. Okay. Two, 5, 5. Add a couple more test cases. Sounds right. I should have tested that one because that one was different from last time. But okay, let's give it a go. Come on, fingers crossed. Okay. I mean, it wasn't that bad. I think I was just too lazy on this one, where I was trying to figure out how I done it. Yeah, let me know what you think about this problem. Hit the like button, hit the subscribe button, join me on Discord, ask me questions, and yeah, let me know how you did. Stay good, stay healthy, and to good mental health, and I will see you next problem. Bye-bye.